All right, good afternoon, everyone. My name is Mike Moore. I work for Nokia. I'm out of Dallas, Texas. I'm the regional product manager for Nokia's airframe data center products. And we're going to talk a little bit about the openEDGE project and the the status of openEDGE and their deployments. And so, as we go to bring cloud to the edge, our operators we find have multiple challenges. I'm really going to touch upon the first two of these. Is basically the remote sites really have limited power, perhaps limited cooling, limited space, and given that traditional data center hardware isn't always best suited to deploy to the far edge. We certainly have examples where we're trying to deploy containerized data centers, hot out containment units to retrofit existing structures, and an effort to bring data center hardware to the edge and to the far edge, and that can cover a lot of cases. It can also incur quite a bit of additional expense, and so we've taken a different approach on this toward with openEDGE, and so. Where within telco, cloudification really all started with the centralized data centers. We started deploying rack mount and open rack version 2 solutions out to that. As we moved from the centralized to the regional and the aggregate data centers, we found that the size of open rack, the 42 OU, was simply not an acceptable size, mostly due to door heights and elevator heights and floor loading in some of the older raised floor central offices. And so, a shorter 36 OU rack is really what we needed to deploy for some of these smaller sites. But then when we get into the aggregate, and especially the far edge data centers, even those, due to power requirements and scaling requirements, didn't really wasn't really an acceptable solution. And so that's where we started the openEDGE initiative. And so openEDGE itself, we have submitted the chassis. It is OCP accepted. This is a still 19-inch, but a 600 millimeter depth. So it's intended to go into smaller smaller cabinets, existing telco cabinets. We do have a 3U form factor. We now have a 2U form factor. If you saw Bill Carter's keynote this morning, he showed both form factors out there. Some deployments need to scale down even lower, right? So the 2U is about as low as we can effectively go. The sleds are either of a 1U or a 2U height, and cooling front to back or back to front. We still keep some of the, so we adopted open rack first, right? And we love the operability advantages of open rack, all front access, vanity-free design, toolless design. And so we tried to take all of those best practices and roll those into openEDGE, right? But even though it is an edge device, we still concentrate on having no single points of failure. And so, we do have redundant fans, redundant power supplies, redundant networking, and so we try to create not only a compact compute unit that could go into far edge deployments, but also something that would be highly available as well. It is fully NEBS compliant. We do seismic zone 4 testing. We have extended temperature ratings. -5 to +45 actually slightly exceeds the NEBS specification. But it's still all built upon commodity hardware, right? So the memories, the disks, the processors, all of that is, we spec out components that are within our temperature ranges, but we still try to use, off-the-shelf, specialized components. So the 2 sleds that we've contributed, and these just received OCP Inspired recognition last week, are the 1U unit and the 2U unit. The 1U obviously is very much focused on compute. Currently with our keeping NEBS specifications, we can put up to a 24-core Intel Cascade Lake processor in there. The TwoU unit, we have slightly better airflow, but it's also intended to, give you a little more storage options, give you a little more networking options, and you can also see by the photo, it will support up to and including, large, full height, full length, double width GPU cards, right? Or FPGA, DSPs, any sort of dense acceleration that might also be required at the edge for video analytics, facial recognition, whatever machine learning, whatever use cases may come up. And so this is a couple of examples of where you may not necessarily be able to bring the data center to the far edge. These are some examples where with the design of openEDGE, which is really designed in a traditional baseband unit form factor, can fit into existing far edge deployments. The couple of examples that I'm showing is one, the FCOB, Flexi Cabinet Outdoor version B. This is a self-contained unit that can be even pole mounted. We honestly haven't had a whole lot of interest in a pole mounted data center at this point, but just showing as an extreme case what this can actually be deployed out to. And then even for kind of dense block cases, we have the dual street cabinet solution, which is basically a micro data center that has battery backup, automatic transfer switches, and in a compute space, all in a TwoU cabinet. So to give you a little review of where we've come over the last year, plus last April we announced openEDGE at the NFV World Congress, started our planning for contributing the specs to OCP. We had a working demo last year at this Amsterdam Summit, and a draft specification was released. We achieved commercial availability on this, and first customer shipments in January of this year. We had a face-to-face workshop out in Mountain View, which was very well attended. We finalized the spec, released it, and got it approved. In the second quarter of this year, WeWin announced that they were going to start producing openEDGE chassis as well, and servers. And over in their booth, you can see what they're offering, and also up in the demo area on the second floor, we have a kind of an interoperability setup where we have multiple vendors, all showing openEDGE-based servers, and obviously ARM servers and sleds, battery backup units, and a second hardware vendor. This is ASUS that is also now announced that they're going to be doing openEDGE chassis and sleds. And so the list of companies that are contributing to openEDGE is certainly growing, besides Nokia. Inventus Power, they're the ones that are doing the battery backup unit, which will supply, I believe, 6 to 8 minutes of battery backup for smaller kind of standalone deployments. The ARM, Marvell, and I apologize to Ampere for not having their name in on this. They're doing an ARM-based sled, which you can see upstairs. I mentioned ASUS, and then Flex. They are coming, and they're going to offer their power supplies as an open platform. And so that that basically covers the presentation on openEDGE. We're going to have an entire track on Edge tomorrow afternoon, where I'll go into more details of the various servers and sled options that are being offered by our partner manufacturers. And in addition to that, we're going to have some additional announcements on other designs that are being contributed to OCP. So that finishes up my presentation. Thank you for your time.